Okay, greetings aspiring scientists. Welcome to my video today on organic chemistry. Should be the final video. I didn't really plan to make this video, but my previous one was already getting to be 1 hour, so I had to cut it. And this video will just serve as a kind of cleanup and conclusion to everything in organic chemistry SL for the IB curriculum. So let's go to my slides. So one thing I realized is I didn't really go into detail about naming of esters and ethers. So I just want to go through some slides on that give examples and some clear instructions. So ethers, I have shown before that they are essentially two names linked together through a linking term. That term is oxy. That should be pretty clear because ethers are two usually alkyl chains, aliphatic chains linked through an oxygen. So ether names take the form something oxy, something else. Now you can have two of the same chain linked or two different chains, one short, one long. If you have two of the same, it doesn't really matter which you put first in the ether name, but if you have a short and a long one, the shorter chain root name will come first in the name, and we don't add any AN like we would with methane, propane, or like methanamine, methanol. Those have the AN attached to the root name. At the beginning of the ether name here, we don't use that AN, so we'll just use meth, eth, prop, bute, for example. Methoxy, ethoxy, propoxy is how it's going to go. That will be followed by the longer chain root name with the appropriate suffix. Usually it's just ane for alkanes. In all the examples I have here, they're just alkanes. So here's some examples. Methoxymethane, both are the same, both are meth. So the first one doesn't have the AN, but the last one has the appropriate suffix for alkanes, ANE. Methoxymethane, under that we have methoxyethane. The longer one appears second and becomes the alkane suffix. Then on the top right, ethoxypropane, shorter one is 2 carbons, so eth, then oxy, then the longer one, propane, 3 carbons on the right. And then just finally, two of the same again, but butane groups, so butoxybutane, butoxybutane. Okay, so nothing that difficult or special here. It's just you got to remember this. Short first, long one last. All right, that brings us to esters. Slightly more complicated. Esters have the C double bond O and CO groups. So esters take the form, ester names take the form something ill, something O8. So the ill term links 2 carbon chains, very similar to what we just discussed with ethers. Now, the root name of the chain linked to a single oxygen will come first. Okay, so there will be some chain that links to only one oxygen in your ester. That is going to come first before the YL term, before the eel term. And again, we'll have no AN or EN or YN on that first name. So we'll just have things like methyl, ethyl, propyl, meth for 1, eth for 2, prop for 3, for example. They continue on. This will be followed by the chain with the C double bond O in it. The root name of that will have the O8 suffix then to finish off the name of these molecules. So I have some examples here. Simplest one, methyl methanoate. So methyl is that CH3 group on the far left. It's just connected to one oxygen. So methyl. And then methanoate. There's 1 carbon on the right, double bonded to oxygen. That's the methanoate group. And so the whole name becomes methyl methanoate. Underneath that, what if we had a 2 carbon chain that has a double bonded oxygen? That's going to be methyl ethanoate. Okay, the second part became 2 carbons long with the carbon-oxygen double bond, so ethanoate instead of methanoate. Another example, top right then, now we have 2 carbons on both sides, both through the single oxygen link and with the oxygen-carbon double bond. So this is ethyl ethanoate, and then maybe the most complex one underneath, bottom right, butyl propanoate. So even though the 4-carbon chain is longer, because it's only connected through the single oxygen, it still goes first, butyl. Then we have the carbon chain that has the carbon-oxygen double bond. That's 3 carbons long on the left, so that becomes propanoate. Butyl propanoate. Okay, these are all esters names, and this is how naming ester works. This might appear on some quizzes I do later, I'm not sure, but you should definitely know it. Okay, good. So that brings us to the very last section in organic chemistry and in structure. Structural isomers. I talked about these a little bit in my previous videos, but we'll go through some more things today. So just review again, structural isomers. It's possible for many compounds to have the same chemical formula, but different arrangement of structures, different 3D arrangements. These are called isomers. Many versions of isomers exist. Some are easy to identify, some are more difficult, but the easiest to identify are different chain isomers, chain positions, branch positions. So I've already shown some of these, but here is an example. C4H10, multiple things have this formula. One example is butane. N-butane just has 4 carbons in a row, but methylpropane also has the formula C4H10. Methylpropane is 3 in a row, and then a methyl branch on the middle carbon there. Then you can see the condensed structural formula underneath there. For butane, CH3, CH2, CH2, CH3, whereas methylpropane, you can write CH, then bracket to say that these are all connected to this 1 carbon on the left, CH3, 3 times. Skeletal formula then for butane, zigzag, zig, and methylpropane. You take that one on the far right or on the far left, whatever you want to think about, and chop it and then put it on the central carbon instead. And it looks kind of like this. I don't know what shape that is, but yeah, different shape in the skeletal formula for methylpropane. Then we have positional isomers. So this is not talking about carbon chains, but potentially functional groups like halogens or maybe alcohols, things that are just sort of one group that we can move around. So all of these things have the formula C5H11Br. We can have 1 bromopentane, 2 bromopentane, 3 bromopentane, all the same formula, but we're just moving that Br from the end to 1 away from the end to the middle. And these do have slightly different properties, chemical and physical properties, so we have to be aware that these are isomers. For example, if you just analyze the chemical content of your chemical, maybe you get the empirical formula, and then maybe you test the molecular weight or molar mass, you find the molecular formula. Even then, you don't know what you have sometimes because there's isomers like this. You need to do further analysis to find out the connectivity of these bonds. Okay, practice. Draw skeletal formulas of all possible structural isomers of compounds with the molecular formula C4H9Cl. So these might have chain or positional isomers. We'll draw the simplest one first. 1, 2, 3, 4. And I'll just put the chlorine on the end. Doesn't matter whether it's left or right, that would be the same molecule. So what would this be? 1 chlorobutane. Okay, what else could we do? We could just move that Cl group to the second carbon. We can have 2 chlorobutane. Different isomer, different chemical physical properties. What else? Okay, we had 1 here, 2 here. Now, if we move the chlorine further to the right, we can still just make 2-chlorobutane. If you would rotate that around, it can make the same thing we have as number 2 here. Again, if we put it on the 4th carbon, it would be the same as putting it on the 1st carbon due to symmetry. You know, this is equal to putting the chlorine on the right side, and this is equal to putting it second from the right. So those are not different, but we need to start making maybe chain isomers. So I can make methylpropane. I can put a Cl on that. So we're going to have a chloro and a methyl. Chloro will come first in the name. We'll put that as carbon 1. As a real functional group, it has priority. So 1-chloro dash 2 dash methyl propane. 3 carbons is still the longest in a row in this. And this would be the same as putting it on the top carbon. We could just rotate that around and get the same thing. It would be the same as putting it on the carbon on the right. We could rotate that around as well. So due to symmetry, these are all the same. But there is one more we could do, I think. We can take our methylpropane chain isomer, and the carbon in the middle still has a hydrogen attached. It only has 3 bonds shown here to carbons, so we have to understand that there is a hydrogen attached. We can replace that with chlorine there. So what is that? 2-chloro-2-methyl. Propane again. Okay, so generally there would be 4 answers to this. Maybe more than that if we consider some crazy things beyond high school level, but this is good enough for us. All right, moving on. So I've already talked about primary, secondary, tertiary alcohols, halogenoalkanes, and amines. Quick review here. Primary for alcohols and halogenoalkanes. Primary carbons are connected to 1 other carbon. Secondary are connected to 2 other carbons, so they'll be in the middle of a chain, whereas primary is at the end of a chain. And tertiary would be connected to 3 different carbons. So in the middle of a chain, also with a branch attached to that same carbon. Amines work slightly differently though. It's just how many carbons are attached to the amine nitrogen. If there's 1, it's primary. If there's 2 carbons attached, it's secondary. If there's 3 carbons attached, it is tertiary. Amine naming is also a little bit unique sometimes. When there are things attached to the nitrogen especially, so for secondary and tertiary amines especially, capital N must be added as a prefix when there are branches on an amine, because numbers only indicate numbers of carbon on a principal chain, right? Nitrogen isn't on that principal chain, therefore does not have a number. But if we add things to it, we need to still have a locant, so we use the big N locant. So on the left, propan, 1 amine, very simple one. 3 carbons, and then 1 carbon-nitrogen bond, and 2 hydrogens on the nitrogen. If we add a methyl group onto the nitrogen, though, we have to say N-methyl propan 1 amine. It means there's a methyl group, CH3, attached to the nitrogen amine. And the amine is on carbon number 1 of the main chain in the left section. Okay, so our main chain is 1, 2, 3. propan-1-amine, but N-methyl, methyl group on the N. Similarly, to the right of that then, tertiary amine, N, N, dimethyl, so 2 methyl groups, each one on the amine nitrogen, propan-1-amine. So again, our main chain is 1, 2, 3, amine on carbon 1, but NN dimethyl to make a tertiary amine. Okay. Very rare. I don't think I've seen that even on IB exams, but it is in textbooks and things, so we should know. Practice 9 then, identify which of these is a secondary alcohol, A, B, C, or D. So the rule of secondary carbons and secondary alcohols is how many carbons are attached to the carbon which contains the alcohol group. So A will be a primary alcohol. We have an OH group on a carbon. That carbon is only attached to one other carbon. Primary, not the answer to this. B, this OH group is attached to a carbon that's attached to 2 other carbons. This is secondary. This is a contender for the answer, and I can tell you it will be the answer. But let's go through the other ones to see why they're not. So C, this OH group is attached to a carbon that is only attached to one other carbon. That is, again, primary. Again, you can draw primary, secondary, and tertiary with a number and then a little circle in the top right. So primary, secondary, primary. Check the answer D then. This OH group is attached to a carbon that is attached to 3 other carbons. It's in the middle of a chain and also on a carbon that has a methyl branch. This is the only example here of a tertiary, often a little bit more rare, but they do exist, tertiary alcohol there. So the answer is, in fact, B, secondary. Then on the right, draw the skeletal structure of propan-2-al, deduce whether it is primary, secondary, or tertiary. So draw the propane, skeletal. On the second carbon, we have an OH group for the alcohol. How many carbons are attached to this alcohol carbon? There's one on the left, one on the right. So this is secondary. Okay, primary would be at the end of a chain like this, propan-1-al. And tertiary can only really start from like methylpropane, if we had an OH group there. If we had an OH group there, that would be a tertiary one. But obviously we need at least 4 carbons for the central carbon to be surrounded by 3 carbons. So it will only start with isomers of butane or methylpropane. All right. So the last thing then is functional group isomers. It's very similar to positional isomers, but with positional isomers, we're kind of just chopping one bond and moving a group around. The types of bonds and numbers of bonds don't really change, just the position. But with functional group isomers, we can see that types of bonds, different types of bonds can actually exist and produce the same chemical formula. Look at ethanol and methoxymethane in the top left. These both have the formula C2H6O, but one of them is an alcohol, one of them is an ether. Very different chemical and physical properties. One of them has OH bond and hydrogen bonding in ethanol. The other one has only carbon-oxygen bonds, methoxymethane, in ether. Underneath that then, we have showing that propanal and propanone, aldehyde and ketone, both have the same molecular formula, C3H6O. And so we can see carbonyl groups tend to produce the same chemical formula, but the carbonyl group can be at the end of a chain or in the middle. producing aldehydes or ketones, different chemical properties. And then on the right, methyl methanoate, CH3O, C double bond O, has the same chemical formula as ethanoic acid, carboxylic acid, CH3, C double bond O, OH, C2H4O2. Again, these have different chemical properties, different types of bonds. Ethanoic acid has the OH group, methyl methanoate does not. So one other thing you might notice is that if there's unsaturation of any kind, there's a double bond, for example, in propanal and propanone, CO double bond. There's exactly one of those. Those tend to follow this chemical formula C3H6O. C3H6O is telling us that there is a double bond or ring somewhere in the structure. Similarly, for methyl methanoate and ethanoic acid, there's also one double bond, carbon-oxygen in that case. So that formula is telling us there must be at least one double bond in this formula. Whereas ethanol and methoxymethane have no double bonds, their formula is telling us there is no double bond in that formula, no unsaturation, or no rings as well. All right, so I think that will bring us to the end of SL, organic chemistry. So as I said, as I promised, I want to show myself doing some naming quizzes. So let's go do those. Okay, so here we are, chemquiz.net/org for organic chemistry. Here's all the settings. So I'm going to set this to 10 problems, types of questions. Identifying class is just too easy, but names, name compounds from diagrams we want, all the possible chain lengths up to 10. We want the simple chains, alkanes, alkynes, alcohols, aldehydes, carboxylic acid, esters, ethers, ketones for chains with oxygen. Other functional groups, yes, amides, amines, aromatics, benzenes. As I said, no thiols though, don't worry about that. Also include halides, phenols, and rings, yes. Show chemical compound formula in problems, yes. Fill in the blank, yes. Multiple choice is too easy, but if you really struggle, you can start by practicing with multiple choice. Probably don't need periodic table. Interactive web page, yes. Okay, so I'm gonna start. So I haven't edited this video in any way. I'll try not to make mistakes, but occasionally I do, even though I've done this many, many times. It is very difficult. Okay, so we've got our list of 10 things we have to name here. So I'll go through my thought process of how to name these. So first one here. This is a ring. So right away, ring is principal chain, biggest ring here. This looks like it's 7 carbons. 1, 2, 3, 4, 5, 6, 7. So this is going to be a type of heptane. I'll start with heptan. Now, I know a ring needs a prefix, cyclo, to show that it is in fact a ring that comes back to itself and bonds together. And this particular ring has functional groups, halogenoalkane, chloro, and amine, NH2. Now the main highest priority one should be that amine. So I'm going to label that as carbon 1, and this can then be called heptan 1 amine. That will be the suffix, and then prefix. If that's carbon 1, I'm going to start counting around the top of this ring. 1, 2, 3, 4. That chloro group must be on carbon 4, 4 chloro, cycloheptan 1 amine. 4 chloro, cycloheptan 1 amine. I'll come back and review these one more time before I hit the submit button. You have to be very careful. It's easy to make mistakes. Number 2, what is the most correct name for the compound? C6H11ClO with this structure. All right, maybe not too bad. It looks like an aldehyde on the right, so we'll have that as carbon 1, and then just count the length of this chain. 1, 2, 3, 4, 5, 6. So this will be hexanal. We don't need locant. Aldehydes are always carbon 1. Then where will that chloro be? 1, 2, 3, 4. 4-chlorohexanal should be. Number 3, again a ring here, very large ring. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be decan. There's no functional groups here, so this will just be decane actually. And we need cyclo prefix. All right, then we've got some branches. We need to label a methyl branch and an ethyl branch. One of them will be on carbon 1, so this is a tough choice. We need to know which has higher priority for being lower. I think it's generally the larger chain, so I'm gonna say 1, ethyl, E comes before M. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Methyl. 1, ethyl. 1, 2, 3, 4, 5, 6. Methyl cyclodecane, I believe. Number 4 then. So we have a long straight chain. It's got fluoro and amine. So amine has higher priority. We need to make that as low as possible. How many carbons in this? 1, 2, 3, 4, 5, 6, 7. Hept N-2 amine. If I start labeling this chain from the right side, this amine group will be on number 2. And then that will leave the fluoro group, 1, 2, 3, 4, fluoro, counting from the right side. 4, fluoro, heptan, 2, amine. Okay, number 5. Alkyne here and bromine. So 1, 2, 3, 4, if we count from the left side for that alkyne. 1, 2, 3, 4, also if we count from the right side. Now if we count from the right side, we can also make the bromo group number 1 instead of 8. So we'll do that. Counting from the right side, this will be oct something ein. So 1, 2, 3, 4, oct 4 ein for that alkyne functional group. Then we also need the prefix bromo, 1 bromo, counting from the right side. Now I know this looks weird with 2 O's, it looks like bromu, but it's still pronounced bromo oct 4 ein. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think that should be correct. Number 6 here, another ring. So right away, cyclo, this will be 7 carbons. 1, 2, 3, 4, 5, 6, 7. Cyclohept. And this is an alcohol main functional group. That needs to be labeled carbon 1. So hept N1 all with dashes, cycloheptan 1 all. Then we'll have fluoro groups on 1, 2, 3, 4, and 5. 4, 5 dash difluoro, 2 fluoro groups. Don't forget the multiplier. 4, 5 difluorocycloheptan 1 all. Should be okay. Number 7, write the most correct name for the compound below. Okay, we've got an alkene, that will be the highest priority group here. Counting from the right side then, 1, 2, 3. And this is 7 carbons, so hept dash 1 dash ene 1, 2, 3. Oh, sorry, hep dash 3-ene. That alkene double bond can be on carbon 3 as the lowest. And then the bromo group, 1, 2, 3, 4, 5. 5 bromo, hept 3-ene. Done. Number 8 then, not too bad, but very long, C10H22O. So this should be 10 carbons, 1, 2, 3, 4, 5, 6, 7, 8, but 8 in the main chain. So oct, N, 1, all. We can label that OH group alcohol on carbon 1. Then we'll have some prefixes, dimethyl, both on carbon 2. 2, comma 2, dash dimethyl, octane 1 all. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that should be fine. Number 9, almost done. Alkyne with iodo group. So we'll definitely be counting from the left here. 1, 2, 3, 4, 5, 6, 7. No, sorry. 1, 2, 3, 4, 5, 6, 7. We don't count the line on the far left. It's still 6 carbons in this formula. C6H9I. 1, 2, 3, 4, 5, 6. So hex dash 1 ine, 1 dash ine for hexine, triple bond, and then also 1 iodo prefix. 1 iodo hex, 1 ine. Should be good. Number 10, last then, another aldehyde, 1, 2, 3, 4, 5, 6, 7. So hept and al, no number needed, but since the aldehyde is carbon 1, then 1, 2, 3, 4. 4 chloro prefix, 4 chloroheptanal. Okay, I'm gonna final check once more before I submit. Is this 4-chlorocycloheptan 1-amine? Yes, I think it is. Is this 4-chlorohexanal? 1, 2, 3, 4, 5, 6. Yep. Is this 1-ethyl 6-methyl cyclodecane? Yes, I think so. Maybe this is the one I'm the least sure about just because of counting. Number 4, is this 4-fluoroheptan 2-amine? Yes. Number 5, is this 1-bromo oct 4-ine? Yes. Number 6, is this 4,5 difluorocycloheptan 1-all? Yes, should be. Number 7, is this 5-bromohept 3-ene? 1, 2, 3, 4, 5. Yes, should be. Number 8, is this 2,2-dimethyl octan 1-all? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay, that should be fine. Number 9, is this 1-iodohex 1-ine? 1, 2, 3, 4, 5, 6. 1-iodo, yes. And then number 10, 4-chloroheptanal, is that right? 1, 2, 3, 4. Yes, should be. All right, I'm gonna hit grade it and see if I made any mistakes so we can analyze it and try to learn. Yay, 10 out of 10, but it took some extreme focus and double checking to make sure I didn't make any mistakes. Got to get all those dashes and commas correct as well. Okay, so I'm gonna do one more like that, just as a final practice so you can see my method of thinking it through. I don't want naming classes. Okay, this should be good. Let's try. Wow, okay. Number one, what's the most correct name for this? Lots going on here, but the functional group will definitely be the amine. So we want to find the longest chain that is on. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, no matter how you count this, this will be a type of octanamine. And it will be on number 1, octan 1 amine. Everything else needs to be a branch then. So we've got 1, 2, 3, 4 butyl branches. They will be attached to 1, 2, 3, 4 carbon 4. 4-4 dibutyl. We've got 2 butyl groups attached on carbon 4. Whichever way that you count your main chain, this should be true. 4,4 dibutyl octan 1 amine. Okay, number 2, correct name for this. This is just a benzene ring, so the benzene name for arenes is the base. Now, what has more priority, iodine or chlorine for being number 1? This is sort of a rule that I didn't discuss, but generally I think the higher molecular weight things would be number 1. But chloro still comes before iodo alphabetically, and it would be carbon 3 then if iodine is carbon 1. Now it might be the case that priority is decided by something else like electronegativity or just period or whatever, I'm not sure. So this is my guess though, higher molecular weight has higher priority. Write the most correct name for the compound shown below. What the heck? C2H2? Oh, it just looks very weird, but it should be ethine. 2 carbons triply bonded and then a hydrogen on each side. That is, I guess, technically the correct skeletal formula. It just looks so weird and big. But yeah, this will just be ethine. No need for locations. No other functional groups. Number 4, what's the correct name for this? This functional group is a carboxylic acid. That means that carbon must be number 1. We have to find the longest chain from that carbon number 1. Excuse me. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This will be heptanoic acid as the sort of base that we're working with. Does definitely have branches though. On carbon 2, there's an ethyl group. So 2-ethyl dash, then a methyl group, 1, 2, 3, 1, 2, 3, 4. 4 ethyl, 4 methyl. 2 ethyl, 4 methyl heptanoic acid. 1, 2 ethyl, 3, 4 methyl. Yeah, that should be correct. Number 5 then, most correct name for this. Again, carboxylic acid, that needs to be number 1. Counting from that carboxylic acid group then, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be a decanoic acid with some branches. And the branches are 1, 2, ethyl group on 2. 2 ethyl, and then 1, 2, 3. 1, 2, 3 methyl. 2-ethyl 3-methyl decanoic acid, very similar to the one above it, but got to get the numbering right. Okay, number 6, correct name for this. Alkene with bromo. We'll count from the left. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So non 3 ene. Non for 9 in a row. Then alkene on number 3. 1, 2, 3 bromo then, prefix. 3 bromo non, 3 ene. Should be done. Number 7, most correct name for this. Alcohol, highest priority functional group. Then longest chain, 1, 2, 3, 4, 5. So this will be pent. Keep that alcohol low. Pent and 2-all, I believe. Counting from the right side, and that will make the chloros 1, 2, 3, 4. 4 dash 4, 4 dash dichloro, pentan 2-all. Should be good. Number 8, most correct name for this. Main thing is the alkyne in the middle. 1, 2, 3, 4, 5, 6. Very difficult to count all those ones that are in a line sometimes. But I do believe 1, 2, 3, 4, 5, 6. We can also see in the chemical formula it's 6 carbons. So hex 1, 2, 3. 1, 2, 3. Whichever way we go, left or right, this is hex 3-ine. And we will count from the left because we have those fluoro groups too. So 2 dash 2, 2 comma 2 dash fluoro, difluoro for 2 of them. 2 dash 2 difluoro hex 3-ine. Should be good. Number 9, correct name for this, another alkyne. I think we need to start counting from that alkyne to make it have the lowest number. So 1, 2, 3, 4, 5, 6, 7. Hept 1 ine. 1, 2, 3, 4, 5, 6, 7. Okay, then if we count from the left, 1, 2, 3, we'll have a methyl group there. And then we'll also have 1, 2, 3, 4, 5. 3, 5 dash dimethyl hept 1-ine. 1, 2, 3, 4, 5. Yeah, that should be good. Last, number 10. Most correct name for this, of course, double alcohols. This is probably a naming rule that I didn't discuss in my videos and probably wouldn't appear on IB exams, but I'll still try it. So 1, 2, 3, 4, 5. 5 carbons, pent, and now I just know that the naming system for this is ane dash 3, 3 dash diol. Pentane 3, 3 dash diol. This is what happens when you have multiple alcohols in the name. We can't just say pentanol, but we need to say pentane. Location diol. And there's nothing else in this, so that should just be the name. Pentane 3,3 diol. Okay, final check. Is this 4,4 dibutyl octan 1 amine? Yes, I think so. Is this 3-chloroiodobenzene? Again, this depends on the priority of iodine versus chlorine. It's either 3-chloro-1-iodo or 1-chloro-3-iodo benzene, but I'm going with this. This is just ethine. Most correct name for this is this 2-ethyl 4-methyl heptanoic acid. 1, 2, 3, 4. Yep, should be. Number 5 is this 2-ethyl 3-methyl decanoic acid. Yes, should be. Number 6 is this 3-bromo-non-3-ene. 1, 2, 3. Yes, should be. Number 7 is this 4,4-dichloropentan-2-ol. Yes, should be. Number 8 is this 2,2-difluorohex-3-ine. 1, 2, 3, 4, 5, 6. Yes, it should be. Good. Number 9 is this 3,5-dimethylhept-1-ine. 1, 2, 3, 4, 5, 6, 7. Yes, it should be. Number 10 is this pentane 3,3-diol. Yes, it should be. All right, I'm going to grade it. We'll see if there's any mistakes. We can analyze it. 8. All right, so some of them are not correct. As I said, all right, so it turns out chlorine has more priority for getting this number lower than iodine. I learned something, or at least I remembered something here from this mistake. So maybe it's lower atomic number or more electronegativity or something like that. That's a rule you can investigate, but probably wouldn't show up on IB exams, that kind of difficult question. Number 3, ethine is labeled incorrect, but ethine is a synonym for this compound and is not the correct IUPAC name. I mean, that's debatable. I think our IB exams do consider ethine to be the name for this, but I do know that most people call this acetylene. So I'm also not sure about that, but all the rest are correct. All right, so that's my thought process for going through these. There's so many little rules and exceptions that some mistakes do happen sometimes, but generally, if you can get these correct, you can get IB exams correct for sure. All right, we'll finish there. So that brings structure to an end. Thank you so much for watching any of my videos if you did, and we'll move on to reactivity and then HL, which I think many people are really looking forward to. That's all. See you next time. Bye-bye.